Okay, so for 10-3, we introduced the idea of trigonometry. Now, trigonometry is the ratio of two sides of a right triangle based on an angle, is what the definition gives here. Now, this is part one of just introduction and setup of trigonometric ratios. Now, for this, make sure you're always drawing the pictures. But I have a picture of a right triangle here, in which I have capital letters for the vertices and lowercase letters signifying the actual side length. So A is this side, and angle A is this angle, okay? Now, there's three trigonometric ratios that we will be learning in geometry: sine, cosine, and tangent, okay? And so for our first one, sine, we're going to be working with angle A on all three of these. So I went ahead and circled angle A, which I highly recommend what you do whenever you're solving any of these problems. Circle the angle that you're working with. So I circled angle A because that's what I'm basing all of these off of. So sine of angle A is the length of the side opposite of angle A over the length of the hypotenuse. And remember, the hypotenuse is always the side across from the right angle. The simplified version of writing that, our three-letter abbreviation for sine, is SIN. We still say it as sine, not sin. We say sine of angle A equals whatever the length of A is over C. Okay? Now this is part of a bigger thing called SOHCAHTOA. That's how you say that. SOHCAHTOA. This is the so part of it. This is to help you memorize the setup of trigonometric ratios. So stands for sine equals opposite over hypotenuse. And sometimes I like to write it like so. Sine equals opposite over hypotenuse. So that's the so part of SOHCAHTOA. Now for cosine of angle A, we do the length of the leg adjacent. Now reminder, adjacent means next to, okay? And we're talking about the leg adjacent, so there's two sides that are next to angle A. But C is the hypotenuse, and B is the leg that is next to angle A. And then over the length of the hypotenuse, C. Our abbreviation for cosine is COS. We still just say cosine, not cos or cos. We say cosine of angle A equals the length of the side adjacent over the length of the hypotenuse. Okay? Now the triangle won't always be shaped this way, so you can't always base everything off this picture. You may have to rotate it, or you may be basing it off angle B. This is just an example of setting it up for just this picture. Now this is our ka part of SOHCAHTOA. Ka is cosine equals adjacent over hypotenuse. Okay? Cosine equals adjacent over hypotenuse. This is very important. This is going to be the easiest way to memorize these. SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And now we're going to learn about tangent. Tangent of angle A would be the length of the leg opposite of angle A over the length of the leg adjacent to angle A. Remember, it's leg adjacent, not hypotenuse. So our abbreviation for this is TAN. We still say tangent. Actually, this one I do often abbreviate and say tan as an abbreviation of tangent, unlike cosine and sine. I still call those the full names. But tan of angle A, or tangent of angle A, equals the length of the side opposite of angle A over the length of the side adjacent to angle A. And this is the last part of SOHCAHTOA. TOA is tangent equals opposite over adjacent. So tangent equals opposite over adjacent. So that's very important for us to understand. SOHCAHTOA. I highly recommend writing this on the top of your paper, at the bottom of your paper, writing it in the biggest words possible, and writing it anytime you see trigonometry, anytime you see sine, cosine, or tangent, writing out the word SOHCAHTOA will really help you to understand it. And once again, that means sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, when we're in class, I have my students repeat this about 500 times. So this is going to be your chance. I want you to say this with me, okay? It's going to be awkward, you just talking to your computer screen. But I want you to say this. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. Remember, you learn through doing. And so today's work is going to be the setting up trig ratios on worksheet. Ignore the rest of this for now, that's from a previous year, but setting up trig ratios on worksheet. That's the only assignment for part 1 of 10-3. And I'm going to show you the worksheet right now, and which I already have SOHCAHTOA written at the top of it because it's so important, okay? So I have this worksheet, and if you're unable to print this worksheet, you are more than welcome to, which I highly recommend, if you can print it, please do. If you're going to do it yourself, like on a separate sheet of paper, please actually draw out the triangles. Normally I don't ask you to write the questions, but this is very important for us to understand. So if you're going to do it on a separate sheet of paper, draw out the triangles if you can't have the ability to print it. So I put on here SOHCAHTOA. Remember, sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And tangent equals opposite over adjacent. Now for each one of these, we're going to set up the trig ratio asked for. We're just doing part 1. Ignore part 2 for now. We'll learn that in part 2 of 10-3. Now, here's how we actually do this. It says Z, so I want to circle angle Z. Okay? Now it says tan. Now what I don't want you to do is to just use this. I want you to rewrite it. I want you to say tangent of angle Z. I want you to be in the habit of putting the angle in parentheses. It's very important that you put the angle in parentheses, okay? It's handy for the rest of trigonometry to always put the angle in parentheses. And we know tangent equals opposite over adjacent. So I look at what leg is opposite of angle Z. Remember, opposite means across. So that's 21 over tangent is opposite over adjacent. Adjacent leg, so not the hypotenuse, that's hypotenuse. Adjacent leg is 28. Okay? Now, when we do part 2, and if you choose the option of doing Math Excel, it will require you to simplify this fraction. So 7 goes into both of these. So I could simplify it to 3 over 4 if I wanted to. I don't necessarily require that. To be honest, when I already did this problem myself, I just left it as 21 over 28. I personally don't care either way. I just know on Math Excel, if you choose to do that option, you're going to be required to reduce the fraction. So it's your choice either way, okay? I'm going to do another example problem. I actually already have the second one, cosine, done right here. So you can look at that picture on Canvas to see. But I'm going to go ahead and do the third one, okay? This is all I'm asking you to do. You're done with this problem here. We're not doing part 2, we're just setting it up. So now I'm going to do number 3, sine of C. So I circle C, I rewrite it, I say sine of C in parentheses equals, and now I look at sine is opposite over hypotenuse. What side is opposite of angle C? Well, that's 28. And our hypotenuse, it's always across from the right angle, is 35. Okay? Once again, to reiterate, you could reduce this fraction. I do not require it, so I'm going to actually leave that one as it is. It's your choice to do either way. Remember, if you are doing this on a separate sheet of paper, please actually draw out the triangle. I think it'll be important for your understanding, more important than just writing this out. So please do so. That's an example of a tangent, cosine, and sine. And that's all you're doing for the I know it's 18 problems, but that's all you have to do is the setup of the trigonometric ratios. And we're going to learn how to solve for missing sides and missing angles in part 2. But that is what the introduction and setup of trigonometry is all about.